Hello students, welcome to my YouTube channel. So in this video lecture we are going to discuss about the scalar triple product. So let us quickly define what is scalar triple product. So if we consider three vectors, vector A, vector B and vector C, they be any three vectors. So we can define the scalar triple product, then their scalar triple product is defined as, so that is the definition, A dot B cross C, A dot B cross C, right? So that is how we are going to define the scalar triple product, and is denoted by that is a box of A vector, B vector, C vector. Now what is the actual meaning of this notation we will explore in the upcoming class, but that is the basic definition of the scalar triple product, that is A dot B cross C, right? So that is a scalar triple product, and since we are saying that this is a scalar, right, triple product, now B cross C will give you eventually a vector. A is already a vector and dot of two vectors is always a scalar. So make a note here that the scalar triple product is a scalar quantity, since dot of two vectors is always a scalar, right? Now let us quickly move to a small example and try to figure it out how to find the scalar triple product. So if I consider a vector A whose value is given to me as 2i minus 3j, and B vector is given to me as I plus j minus k, and likewise I consider C vector to be 3i minus k, and if somebody asks me find the scalar triple product, that is a box of ABC. So all of us know that yes sir, the definition of scalar triple product is nothing but A dot B cross C, A dot B cross C. So first of all we need to find what is the value of B cross C, right? So we know how to take the cross product between two vectors. So B cross C is nothing but, take the determinant I, j, k, and now write the elements corresponding to B, that is 1, 1 and minus 1, and now corresponding to C, that is 3i, 0, j and minus 1, k. And now if we expand this, so I times this is minus 1 minus 0 minus j times, so again minus 1 plus 3 and plus k times 0 minus 3. So eventually what is the required vector which we get from this B cross C, that is nothing but minus I cap minus 2j cap minus 3k cap. So that is the value of B cross C. And now what I have to find? I have to find, sir, nothing but A dot B cross C. A dot B cross C. What is my A vector? Just go back, that is 2i minus 3j. So that is 2i minus 3j dot with minus I minus 2j minus 3k, because that is nothing but the value of B cross C. And now just take the dot, that is 2 into minus 1 plus minus 3 into minus 2 plus 0 into minus 3, right? And this is nothing but minus 2 plus 6, that is 4. So therefore A dot B cross C is nothing but 4, that is the box of A, B, C is 4. Yes, it is a scalar quantity. But now the question arises that yes, is there any other way to find the scalar triple product, or in all these questions we have to follow the same approach? That is the first question which must arise into your mind. So let us see, yes, if there is any other way. Now make a remark. So if A vector is given to me as A1 I cap plus A2 j cap plus A3 k cap, and now if I consider B vector to be B1 I cap plus B2 j cap plus B3 k cap, And likewise, if I consider C vector to be C1 I cap plus C2 j cap plus C3 k cap, then the box of ABC, then the box product, that is ABC, is nothing but the determinant corresponding to these three vectors. So this was nothing but A dot B cross C, and that was equal to the box. And how to find the box? That is the determinant of these vectors A1, A2, A3, then B1, B2, B3, and corresponding to the third row is C1, C2, C3. And yes sir, we know how to calculate the determinant of this 3 cross 3 matrix, right? And now the next question which must arise into our mind is that yes, how is this A dot B cross C equal to this determinant? Let us look into the proof of this now. So proof. So since it was given to me that A vector is A1I plus A2J plus A3K, B vector was B1I plus B2J plus B3K, and similarly C vector was C1I plus C2J plus C3K. Yes, so we have considered these three vectors. First thing which we need to find is B cross C. So let us quickly see what is B cross C. Already we know how to calculate the cross product between two vectors. So this is I, J, K. Now corresponding to B, this is B1, B2, B3. Likewise, this is C1, C2 and C3. Let us expand this. So I times, so this is B2, C3 minus C2, B3, minus J times, so this is B1, C3 minus C1, B3, plus K times, K vector times, K cap times B1, C2 minus C1, B2. So that is nothing but the cross of B and C, that is B cross C. The required value of B cross C is this. And now what I need to find? I need to find A dot B cross C. So what is my A vector? Sir, it is nothing but A1 I cap plus A2 j cap, yes, plus A3 k cap. Is it clear? And now if I take the dot with B cross C, what is my B cross C? Sir, this is my B cross C, that is a star. And now we know how to calculate the dot product between two vectors. Let us quickly write the dot product between the two vectors. So this is nothing but A1 times, that is B2C3 minus C2B3. Yes or no? Next, minus A2 times B1C3 minus C1B3. And likewise, this is A3 times B1C2 minus C1B2. So that is the dot product between the two vectors. And now we need to observe one thing very, very carefully, that this step is similar to the determinant of this vector, that is A1, A2, A3 as the first row, B1, B2, B3 as the second row, and similarly C1, C2, C3 as the third row. Quickly observe, they both are equal. We know how to expand the 3 cross 3 determinant, right? So eventually what we have observed that yes, A dot B cross C, which was equal to the box of ABC, gives us nothing but the determinant of a 3 cross 3 matrix with the first row corresponding to the vector A, second row corresponding to the vector B, and third row corresponding to the vector C. So that is the short way to calculate the scalar triple product. So let us quickly observe, if we take the same example now, and the same example which we have considered in the beginning of the class, example number 1, and now let us quickly find out the box product using this concept of determinant. So the example which we have taken was, the A vector was 2i minus 3j, the B vector was I plus j minus k, the C vector was 3i minus k. Now let us see how to calculate the box product of this. So that is A, B, C. Just write the determinant. So corresponding to A, we have 2i minus 3j plus 0k, right? Next we have I plus j minus k, and corresponding to c we have 3i 0j minus k. And now just expand it, expand along row 1. So this is 2 times minus 1 minus 0, right, plus 3 times, yes, corresponding to 3, just hide these rows. So this is minus 1 plus 3, minus 1 plus 3. So this is nothing but minus 2 plus 3 into 2, that is 6, minus 2, which is equal to 4. And just observe, go back and check it out, this was also 4. So that is the short way to calculate the scalar triple product, that is using the concept of determinant. Now in the upcoming class we will explore few more properties corresponding to the scalar triple product, and then we'll move to some very important and interesting questions. Thanks for watching the lecture. Stay tuned. Thank you so much.